What if the denominator in our exponent is even? Well, in that case, just in evaluating x to the p over q, we have an even root hidden. And so the x to the p over q function has 0 to infinity as both its domain and range. The x to the p over q function is 1 to 1, so we're only going to get a single solution if we get a solution at all. But x to the p over q equals c has no solution if c is negative. And if an apparent solution to x to the p over q equals c makes x negative, this solution is extraneous. If we think we have a solution, but it actually requires us to take an even root of a negative number, something went wrong. We don't really have a solution to our equation. So here are a couple of examples. In this example, we have x to the 3/2, and it's not isolated. So the first thing we need to do is to isolate our x to the 3/2. We'll add 9 to both sides. 3 times x to the 3/2 equals 6. We'll divide both sides by 3. X to the 3/2 is 2. And now we can rewrite this. We have x to the odd over even is a positive number. We can say this is equivalent to x equals 2 to the power 2/3. Now we go and plug 2 to the power 2/3 into the calculator, we get an awful decimal. So we know that we need to just rewrite that as the cube root of 2 squared. X is the cube root of 4. So let's check this, right? X is the cube root of 4. So we have 3 times the cube root of 4 to the 3/2 minus 9. And putting the cube root of 4 in parentheses to the power 3/2 into our calculator, we get that that's just 2. So we have 3 times 2 minus 9. That gives us 6 minus 9 is -3. Here we have 2x minus 1 to the 3/4 equals -8. Our power expression is isolated. We see that we have an even denominator. So this equation says an even root equals a negative number. It has no solution. Once we recognize that we have no solution, we stop doing algebra. So there's nothing else to do on that one. So let's summarize our rules for working with equations with rational powers. First, if P and Q are both odd, there are no problems. X to the P over Q equals C is just directly equivalent to X equals C to the power Q over P. We can just take the Q over P power on both sides and not worry about it. If either P or Q is even, X to the P over Q equals a negative number has no solution. If P is even, we're using the even root property. We have to introduce a plus or minus. If Q is even, solutions to X to the P over Q equals C are also solutions to x equals c to the p over q. But we have to check for extraneous solutions. And of course, we don't have a case for when p and q are both even, since we're assuming that our rational exponents are always written in lowest terms. And if they're both even, they have a common factor of 2.